All right, Joe is on a flatbed car going 0.85 C straight toward you. I changed all these on the assessment to right and left. But we'll just go with this, right? All right, so there's Joe. And they throw the ball forward. So this car is coming at you at 0.85. They throw that ball relative to themselves at 0.62 C, right? And of course, if you added those using non-relativistic Galilean transform, you would of course get a number bigger than C, which is not possible, right? So we use the Lorentzian transform and we add it, and it's going to be the sum of V1 plus 2 is going to be 0.62 C plus 0.85 C all over. And the formula is weird in the data packet. I can't even remember what it is. It has the minus in there. Minus is for subtracting, plus is for adding. So 0.62 C times 0.85 C over C squared. And of course the C's here are going to cancel out. Right? The C's in the top don't cancel out, just as well. It's got to have some actual units of speed there. So 0.62 plus 0.85, and this is all in parentheses, divided by, and then also in parentheses, 1 plus 0.62 times 0.85. All right. And I get the first answer, so I get 0.963 C. Right? Now, what if he throws it backward in his frame of reference, right? So what if Joe is here instead? He throws that ball backwards. Of course, you would then subtract, right? Right? So let's say it's this way now. Then you would subtract, so V1 minus V2 is 0.85 minus 0.62 all over 1 minus 0.62 times 0.85. Notice I'm not writing the C's. You need them in the numerator and the denominator. They're going to just cancel out like that. All right, so here we go. I'm going to parentheses 0.85 minus 0.62 end parentheses divided by beginning parentheses 1 minus 0.62 times 0.85. And that's 0.486. So we would see that ball going away from us. It would still be going to the right, though. So we'd still be going 0.486 C to the right. And this would, of course, be to the right. And that's how I put it on the assessments, just because I think straight toward you is kind of hard to wrap your mind around. 0.486 C to the right. It still would be going to the right that fast. So notice that sums are smaller, asymptotically approaching the speed of light, and differences are larger. Now the reason for this is that as you throw that thing backwards in there, right? Remember this, I'm not drawing this picture right. This frame of reference would be all shrunken down at 0.85 C. These people would all be shrunk, and the car would be like, wouldn't look any shorter, but it would be like, and those wheels would be like, wouldn't be even circular, right? And the person would be like, they'd be all thin like that, right? And so when they throw it backwards, it comes out of that frame of reference and uncontracts, right? It kind of dilates back to a more normal speed, and so we get the difference is actually bigger. And when they throw the ball forward, you're increasing the velocity, right? And so anyway.